Hi, I'm Satish and I'm responsible in algorithm software.
Hi, I'm Khurshid and I'm responsible for electronic and mechanic.
Hi, I'm Razia, responsible for audio and visual recognition and software, but we share responsibility together. RKS!
Hello, our scenario is about grandma and grandson. Her grandson is away for a while to study. She is lonely. Baymax is there to take care of her and keep her company. These are innovative features that we did a lot of research to find and tested them several times. These abilities made our Baymax more real and help us give him life. It has many uses and it's inspirational. Hopefully next team will use this feature too.
The first feature that we added to our robot to make him come to life and be more realistic was his ability to speak and understand what we're telling him, which was made possible by adding voice recognition and dialogue system to the robot. This is really exciting for us to be able to talk to our robot and make conversations with him. So we really tried our best to make this come to life and happen. For our first code, we used Google's speech recognition, which uses Wi-Fi, and that's not allowed in the competition. So we did some research and found out some libraries that could help us do this without Wi-Fi. In our researches, we found the WASP library that we had in our actual code. So we used it here, WASP and Pi-Audio libraries. And here when I say ouch, it's going to print, hello, I'm Baymax, your personal healthcare companion. But we added different possibilities to have sustainability and have our code be more reliable. So when I run the code, ouch, he's going to respond to me.
Because of Baymax's balloon-like body, it is difficult for him to move things around. With the research that we've done, we found out that it's very important for health workers to have the ability to carry things around. Because of that, we've added a creative innovation that has two robots with the ability to lift and transport. In the process of making these two robots, we first made a prototype with Legos that you will see in this test.
So after testing, we saw that the center of balance of the robot must be maintained. So to help add the sustainability, we designed a more accurate mechanism in solid, which is going to be made of plexiglass. So here you can see it has an elevator and a basket. The basket is attached to a belt and it moves up and down.
For mapping and where every robot should be placed, we use April tags, which is a sustainable way of finding the robot's position using a camera. All of our robots have the ability to detect the tags, and our coordinator will tell us the ID of the tag and our robots will move towards it.
We use these libraries to detect any April tags present in the picture. Then we defined a function that gives us back the information that we need, like the ID and the center coordinates. Here we gave the main code the count that you should be using, and it will draw a circle around the tag and put a text on top of the tag regarding the ID. This is the ID. For testing, we used OpenCV, but for our real robot, we're using OpenMV and the module to identify the tag's information. Here, as you can see, the ID is shown on the terminal.
So this is the design of our main robot. We are trying to make him balloon-like and round. This is the blower that will be turned on by voice command. And this is the camera that is placed on the front of the base.
First, we made a small Baymax prototype from plastic bags and gloves to find a perfect pattern and a way to glue it together. Then we sewed a tablecloth, but it obviously didn't hold air. Running a blower continuously through the performance was too noisy, so we switched to a thin, airtight fabric and used heat pressing to seal it together. We are thrilled to keep improving our design and create the Baymax we wanted.